Okay, so let's take a look at another one of these more involved gas stoichiometry problems. So they have a lot of words. It says a sample of methane gas having a volume of 2.80 liters and 25 degrees Celsius and 1.65 atm was mixed with a sample of oxygen gas having a volume of 35 liters, 31 degrees Celsius, and 1.25 atm. The mixture is ignited to form carbon dioxide and water. Calculate the volume of water vapor formed at a pressure of 2.50 atm and a temperature of 125 degrees Celsius. There's a lot going on here. Since I have so many things, I need to have my balanced equation. So I'm starting with CH4. It's a combustion reaction, so I'm adding O2. And it told me that I made CO2 plus H2O. And then I need to balance that. My carbons are balanced. Hydrogen, I need 2. And then I have 2 plus 2 oxygen, so I need 2 there. Okay, so the methane had a volume of 2.80 liters, 25 degrees Celsius, and 1.65 atm. And it was mixed with this oxygen gas, which was 35 liters, 31 degrees Celsius, and 1.25 atm. It's ignited to form carbon dioxide and water. So it says calculate the volume of water vapor, question mark, liters, formed at a pressure of 2.50 atm and a temperature of 125 degrees Celsius. Before I even tackle this problem, I want to make these into Kelvin. So this is going to be plus 273, so I have 298 Kelvin. I have 304 Kelvin. And I have 125 plus the 273, which gives me 398 Kelvin. So I'm reacting these two here. And then I want to know how much of this I produce. Anytime I start a problem off and I have 2 reactants, I have information on 2 reactants, and essentially I have R for both of these, so I have a temperature. The thing that I'm missing here is moles. If I have 2 reactants, I actually have a limiting reactant problem. And so I need to calculate for both of these the number of moles. So I need to do PV equals nRT for my CH4. So pressure is 1.65 atm. Volume is 2.80 liters. N is what I'm solving for. R is 0.0821. And my temperature is 298 Kelvin. I also need to do PV equals nRT for this set of information. So my pressure is 1.25 atm. My volume is 35.0 liters. My moles is what I'm looking for. I have 0.0821 liters atm, moles Kelvin, and my temperature is 304 Kelvin. Go ahead and pause and solve those. Okay, now that I have the moles of my CH4 produced and my moles of O2 is produced, I need to figure out which one limits. So I need to do my 2 stoichiometry problems. So here's my first stoichiometry problem. I'm going to take these moles, and they're going to be short because I'm starting with moles. So I have moles of CH4. I want to get rid of moles of CH4, and I want to figure out how many moles of H2O I have. I need to put numbers in, and since it's moles over moles, I'm going to go back up into my equation here, and I'm going to take this 2 here for the H2O, and I'm going to take my invisible 1 here for the CH4. And then I'm going to do the same thing for my second one, but this time I'm dealing with moles of O2, so I have 1.75 moles of O2. I want to get rid of moles of O2. I want to convert to moles of H2O. Again, I'm going to go back up to my balanced reaction, and I see that I have 2 moles of H2O, and I have 2 moles of O2. So now go ahead and pause again and take a look at what the answer is. Okay? So here are my two answers right here, and you see that I can only make as much as my least number of moles, and so my least number of moles, it's a limiting reactant problem, is 0.378. So this is extra information that I don't need, and so now that I know my moles of H2O, I can go ahead and do PV equals nRT because I need to know for my liters that I want to solve for. So pressure is 2.50 atm. V is what I'm looking for. My moles is 0.378. Oh, I'm going to run out of room here. I have 0.0821 liters atm. Oh, I don't like to do this, over moles Kelvin. And my temperature is 398 Kelvin. I go ahead and solve all of that for my volume to get my final out volume. So 0.378 times 0.0821 times 398 divided by 2.50 gives me 4.94 liters of H2O produced. It's a lot of work, but it's not anything that we haven't done before. So we have done limiting reactant. So here we had 2 sets of reactants. They were both gases. We had to figure out how many moles we had of each. We had to do stoichiometry, which is really just a mole ratio, to figure out which gave me the least number of moles, so which one limited. In this case, my CH4 was my limiting reactant. And then I had to take that small number of moles and do PV equals nRT to solve for the amount of liters of H2O that was formed.